Hi
Hi,
everyone, good evening.
Yeah, good evening.
hi, I'm Ramya, and I'm going to talk about AI Project 1. I'm part of Group 7, and our team developed solutions for the given task related to DFS, BFS, Uniform Cost Search, Greedy BFS, and A-star search algorithms with flowcharts. And also, we are going to present it live demo with the result screenshots and flowcharts. So many AI problems can be modeled as a search problem with the goal being accomplished and the goal using the state transformation rule from beginning state. As a result, the scope of the search has been narrowed down. All the search methods can be broadly classified into two categories. The first one is uniform search algorithm and heuristic search algorithms. Uniform search is a term that refers to the group of period algorithms that cover a broad variety of applications. These methods are brute force applications and they have no additional information about the search space. The only information they have is on how to traverse or visit the tree's nodes. As a result, blind search algorithms are often referred to as a ignorant search algorithms. The search algorithm, which is brute force in nature, generate the search tree without any domain knowledge. They differ from the informed search algorithms in that they look for the goal when a node is created or enlarged, and they have no prior knowledge of how to approach the objective. Whereas heuristic search algorithm is a technique for solving a problem faster than the traditional approaches or for estimating a solution when traditional method fails. So we frequently exchange one of the optimality and completeness accuracy. Therefore, this is the form of a shortcut. When searching for a solution, extra information is used to identify the next stage in the process. So greedy BFS and A star search heuristic algorithms are the are comes to the heuristic methods. So we are going to see how these can solve the given problem with the screenshot of the results and also with the live demo, and flowcharts are also included with the live demo. Handing over to Alekia for the further process to explain DFS.
Hello everyone, now I'm going to explain about the breadth first search algorithm and BFS. We used to call this as a BFS algorithm in a shortcut, and BFS is a search operation for finding the nodes in a tree, and this algorithm works breadthwise and traverses to find the desired node in a tree. It starts searching operation from the root nodes and expands the successor nodes at that level before moving ahead, and then moves along breadthwise for further expansion. And it is an algorithm for graphing data, searching trees, and traversing structures, as BFS stands for breadth first search and is implemented using queue. BFS traverses the tree level wise, and the algorithm visits and marks the keynotes in a network in a fast and accurate breadthwise manner. This approach explores all nodes near to a single node in a network, and we need to know that BFS only connects to these nodes one at a time. After visiting and marking the beginning node, the algorithm moves on to the next unvisited node and analyzes it. All nodes are indicated once they have been visited, and these iterations continue until all the graph nodes has been visited and marked correctly, and it is used in finding the shortest path spanning tree and in connectivity. And here is the flowchart for the breadth first search. And coming to this flowchart, we start and initialize the nodes and the edges and visit the start node in a queue, and we will check whether the queue is empty or not. If it is not empty, then we will remove node from a queue and point to the adjacent node. And later we will check if the first adjacent linked list is completed or not. If yes, we will go back to the queue. If not, then we will check the node whether it is already visited or not. If it is visited, then we will move to the next node of the adjacent list. If it is no, then we will go to put the node in a queue. And if the queue is not if the queue is empty, then we will add all the nodes in an ascending order to the queue, and we will end. Coming to the next slide, here the code, and in this code I just given the starting node as a, and it is the graph, and later my friend will continue.
Hey, thank you, Alekia. And now let's discuss about depth first search algorithm. In this, we can also call it as DFS. It is one of the recursive algorithms. It transfers the graph or a tree depth-wise. Then it is known to be a depth first search algorithms as it derives its name from the way it functions. The DFS uses the stack for its implementation. We use stacks for its implementation, and the process of research is similar to BFS. The only difference lies in the expansion of nodes, which is depthwise in this case. And here we can see the flowchart of depth DFS. First, we start, and then we need to give input for nodes from the starting node. And our nodes are like A, B, S, K, Y. We need to check with all the nodes first A and B and S, K and Y. Then next we need to verify the adjacent list of nodes. And then when we reaches the endpoint of our nodes, if it is yes, the loop will directly go and it will end. If not, if it is no, then it will re-verify the previous nodes, and then the loop continues. And the next slide, please. And here is the output of my DFS algorithm. And next, Mahesh Kompale will continue.
Yeah. Yeah, my name is Saram. I'm going to explain about greedy best first search algorithm, and my team member Mahesh also going to explain the same algorithm. Coming to the introduction, as my previous friend said that they discussed about breadth first search algorithm and depth first search algorithm. This is the greedy best first search algorithm is the combination of the both algorithms. The greedy best first search algorithm always chooses path that appears to the most appealing at the time. It is a result of combining both the previous algorithms, that is depth first search and the breadth first search algorithms. It makes use of the heuristic functions as well as a search. We can combine the benefits of both methods with the best first search as well as the depth first search. At each step, we can use best first search to select the most promising node. We can expand the node that is closest to the goal node in the first search process, and the closest cost is determined using heuristic function. The flowchart is explained by Mahesh Kompally.
Mahesh, unmute yourself.
Yeah, hi. I'm going to explain about the flowchart for the greedy best first search. When first of all, we will create a two list open and closed, and we will put the initial nodes in the open list, and we will check whether the nodes, what are the nodes connected to the source node, and we will traverse to the nearest node, because to reduce the to increase the efficiency of the algorithm. And then we will check is the goal node or it has any other nodes. If it is the goal node, then we will stop the execution of the one. And if it is not the goal node, we will go to the nearest nodes, so that we can check this process will be continued until we reach the goal node. Once we reach the goal node, we will stop the process and we will show the output. We give the optimal path. And next, this is the program output, and here I performed the greedy buffer search by taking a start node as A, F, Q, and Y and E, and the goal node as G. And this is the path. These are the paths obtained when I performed the greedy best first algorithm to the graph. And next, my friend will continue the presentation.
Hey, hi, this is Shivalaxmi Vannam. Myself, I did uniform cost search algorithm. First, what is uniform cost search algorithm? It is a traversing a weighted tree graph. It comes into a play when a different cost is available for each edge. The goal of UCS is to find a path to the goal node which has the lowest cumulative cost. It expands nodes according to their path costs from the root. It can be used to solve any graph or tree where the optimal cost in demand. A uniform cost algorithm is implemented by the priority queue. It gives maximum priority to the lowest cumulative cost. It is equivalent to BFS. If the path cost of all edges is the same. The advantages of uniform cost search algorithm is it is mainly used in optimal because at every state the path with the least cost is chosen. The disadvantages is it does not care about the number of steps involved in searching and only concerned about path cost due to which this algorithm is stuck in infinite loop. Now my friend Ryan will explain.
Yeah, so here's a flow chart created to kind of demonstrate how the uniform cost search works. I know it's kind of blurry. It was just a little too big for the slide, but starting at the starting point, we go down and we implement 3 methods, one for edges, one for nodes, and one for the node comparator. Then we go down and implement the UCS algorithm. It will initialize a priority queue. It will add a start node to the priority queue, and then it will find the least cost child node. It will then take the current node and store it in a visited queue, and then expand to a child node. If the target node is reached, it breaks the function. Otherwise, it goes back to find the least cost child node and continues on until it expands all the nodes and finds the most optimal path. Once we get down to main, it sets a start node and a goal node, and it finds the least cost path between the two, and then it outputs the path to the goal node. Right here is our algorithm results. As you can see, starting from Q finds the least cost path to the goal node. The other one starting from A also finds the least cost path to the goal node. These other ones also demonstrating the same things at different starting points. One starting from Y, the next starting from F, and the last one starting from E.
Next, I will go with A-star search algorithm. It is one of the best technique used in pathfinding and graph traversals. It is really a smart algorithm which separates from other algorithms. These are mainly used in games and web-based applications, and for using maps also. These algorithms will play a vital role to find the shortest distance. It has mainly depends upon the 3 parameters, g of n, h of n, and f of n, where f of n is equal to g of n plus h of n. It will calculate. The g of n is nothing but the actual cost of traversal from initial state to the current state, where h of n is the estimated cost of traversal from the current state to the goal state, where f of n is the actual cost of the traversal from the initial state to the goal state. Coming to the flow chart, first initiate n, and we have to put that n in the open list. Then we have to take care about the distance, that is hysteric function h of n. Then this h of n will go to the open list, and that initializer n will come to the closed list. So remove from open list and put on the closed list and save the index n. Then it will check the condition whether it is greater than the. First, it will check the possible nodes in which it will go. If it will go to the shortest distance and use the distance which is has highest. Similarly, this process will continue till to reach the goal node. It is same explained in the form of algorithm. Next, these are the outputs of A-star search from node A to G, from A to G, goal node. Similarly, from Y to start node Y to goal node G, and from start node F2, goal node G. This A star search is mainly often used for the common path finding problems in applications such as video games, and lot of video games will mainly depend upon this A star for positioning system. Now we will show the live demos how the outputs will be. Start with BFS.
Hamshi, you can start with yours. Later we can share
Sure.
other ones.
You can see my screen, right?
Yes.
Yeah. Then this is the program. Yes, from start node A to the goal node G. It's the output. Similarly, we can do for any start node to end node. I have written this program in Java using priority queues and all the stuff. Like, just have created the nodes initially. After creating the nodes, I have initialized the edges. Then I have written the priority queue logic to find the shortest distance in a most possible way. In that way, I have written this program. Now we can change any start node and we can run. It will get the shortest distance path for A star search queue. Yeah, from A to G. Yeah, that's it. Anyone can share their live demo. Thank you.
Stop sharing your screen.
You can share yours, Pradeep.
You cannot. First, you need to stop sharing your screen. Then.
Okay, sorry.
Are you able to see my screen?
Yes.
Hello?
Yes,
Yeah,
yes.
okay. Yeah, in this DFS, it should be A, B, and S, K, and Y. And now let's see our output living demo. Let me change it to A. Mm, so
Once refresh the compiler, copy paste.
yeah, this is my output for node B. And let me show you for node A. Yeah, if our starting node is A and then node will be B. And as in our question, our next node will be ABS. It will be S. If our starting node will be S, then the end node will be P. And next we need to check with K and Y. Yes, you can see here a starting node will be K and then node will be Y. Let me show you for the final node. I don't know why it is taking time. Yeah, this is my output for starting node Y and then node will be P. And that's it. Anyone can share their screen and you can show your output.
Now I'm sharing my screen and here is my code for the BFS. Here I just give a start node as A and execute. And the path for the start node A is this and A, B and Q to rest is all. Now I'm giving according to the question. Now I'm giving start node as Q and executing. And here is the path for the starting node with Q. Now I'm giving start node as S and start with S, B, H and I'm traversing all nodes for this path. And now I'm giving J and here is the path for this. And finally I'm giving with D and executing. And it starts with D, J, T, Y and traversing all nodes through F. And here is the path for that. And then stop sharing my screen and my friends can continue.
Um, Thank you. Now I'm going to execute the greedy best first search. This is the program for the greedy best first search. I created two classes: the graph class, the node class, which is used to which helps the program to take the graph as an input and execute it properly. In here, I took a method, greedy best first search, and I give all the starting nodes like A, F, Q, and Y, and all the goal and the goal node G for everything. And now I'm going to execute this one. Just a second. Yeah, and these are the paths obtained when I executed using the greedy best first search. For if I started with the node A, it's go to the B, and when it has similar, and then K to Y to and D, and similarly, I got all these paths using the greedy best first search algorithm. Thank you.
All right. Here's the uniform cost search. This is just the main to run the program. See, we have our edges added and the nodes. First we got from node F to G. This will be from node A to G. from node. Q to G. And I'm pretty sure the last one was S. Let's see. Live demo works fine.
Yep, I think we are done with all line demo, right?
Yeah, then we can go with the conclusion part.
Yeah, conclusion part.
I will explain about the conclusion.
Will be going to explain about conclusion.
I think we
Prabha
missed
or-
it. Did we explain A star search algorithm?
Yes.
Yes.
Hello everyone, I am Prabha Nyopani and I'd like to conclude the video presentation. And likewise, my team members already explained about the different algorithm, their flowchart, implementation, and also through the live demo, they demonstrate the output of the code. So while completing the project, we distributed project work ourselves and ensured that everyone had access to the resources needed to work on algorithms. BFS is used to find the nearest goal in a short period of time, but it consumes more energy as all the nodes are stored in a memory. Meanwhile, DFS consumes less memory, but the state may enter into infinite loops. Also, we find the runtime for greedy algorithms is much easier than other techniques. For the uninformed cost search at each state, the least path is followed and it is considered the optimal solution. However, it requires large storage and the algorithm can stuck in an infinite loop. Likewise, in DFS, a search algorithm is considered to be the best and most complete process for finding the optimal path and solving complex problem. To ensure this algorithm is complete, if every action has a fixed cost and the branching factor is finite. And at last, I'd like to thank Dr. Dai for giving the opportunity to learn about different algorithms. And it's been a great thing to work as a group. Thank you.
Thank you, everyone.
Thank you.